Good afternoon, everyone, and welcome to Grad Slam. I'm Lila Roop, the Interim Dean of the Graduate Division, and it's my great pleasure to be your host for this afternoon's exciting event. In 2013, our former dean, Carol Giannetti, came up with a brilliant concept for Grad Slam. And now, here we are, celebrating our 10th anniversary. As you probably all know already, the idea is for students to present their research and its importance in 3 minutes. When graduate students are going on the job market, we talk about their elevator speech, how they will describe the research if they're in the elevator and someone says, "What are you researching?" But as you can see from our finalists, these are much more than elevator speeches. And I'm now going to admit, not only that I never could have done this when I was a graduate student, but it was even worse than that. I had so much trouble talking about my dissertation and why it was important that I made up a fake topic and a fake title. And then, when people asked me what my dissertation was about, I would say, well, you know, it's really so hard to explain that I've made up this fake topic and fake title, and then I would tell them all about that, and by the time I finished, nobody asked me what my dissertation was really about. So, the showcase has a new look this year, which those of you who've been here before might notice. In order to showcase the diversity of research across campus, our finalists represent 9 different disciplinary clusters. Each one of them already won $1,000 at a preliminary round organized by field. In addition, there are no longer any restrictions on the number and content of slides that the presenters can use. They have to be original to the student and not generated by a professional, but you'll see there are a lot of different kinds of images that our presenters will be using. We've also expanded our judging panels to include both graduate and undergraduate students, in addition to representatives from the UCSB staff and faculty and community members from the broader Santa Barbara community. And I'll be introducing those judges in a moment. Finally, we've simplified our scoring criteria, and presenters are now evaluated on 4 different elements. So you can kind of think about these when you are watching these performances: accessibility, organization, delivery, and engagement. But one thing remains the same. Each talk has a 3-minute time limit, and students rapidly lose points if they exceed the 3-minute mark. This year, we had 57 grad students from across campus participate in the Grad Slam preliminary rounds, and we were assisted in those rounds by over 40 judges in these rounds. If any of our preliminary presenters or judges are in the audience, would you stand and we can give you a round of applause? We'll give you a round of applause anyway. We're really proud of all of the students who competed, because part of the whole point of this exercise is to learn how to do these kinds of things as a sort of professional development. Our grand prize winner today will receive $2,000, and our 2 unranked runners-up will each receive $1,000. Audience members, both in person and online, will also have a chance to vote for the People's Choice Award winner, who will receive $500. The winner of the final round today will go on to compete in the UC-wide competition, which will be held May 5th and hosted by UC President Michael Drake at the LinkedIn headquarters in San Francisco. So this year, we're hoping for a Santa Barbara winner. It's not an easy job judging Grad Slam, and especially when it comes to the exceptional finalists you'll see today. We're grateful to our illustrious judges who diligently watched and evaluated video versions of our finalist talks last week. This is another innovation, partly a result of our experience with the online competition during the pandemic. All of these finalists presented in person in the preliminary rounds, but they then produced a video talk that was judged in advance, and now they'll be back on stage in person. We're excited to announce the results of the judging at the end of the show today. For now, it's my pleasure to introduce and recognize each of our final round judges. Representing UCSB faculty from the Humanities and Social Science side of campus is Sabina Frühstück, Professor of East Asian Language and Cultural Studies. Representing UCSB faculty from the STEM side of campus is Mark Sherwin, Professor of Physics. Representing UCSB staff is Joe Sabato, UCSB class of '97 and Deputy Chief Information Officer. Our graduate students are represented by Jeff Meyerhoff, doctoral student in biomolecular science and engineering, and the 2022 UCSB Grad Slam winner. UCSB's undergraduate students are represented by biology major Marina Stoilova, who was the 2022 Undergrad Slam runner-up. To round out our judging panel, we have two Santa Barbara community members. Dr. John LaPuma, UCSB class of '78, is a board-certified specialist in internal medicine, as well as a speaker, chef, and author. Our other community member is Dr. Carrie Tobes, licensed clinical psychologist and president of the Tobes Foundation. So please give a big round of applause for our final round judges. Just in case you're wondering, we asked our judges to identify any potential conflicts of interest ahead of time to ensure a fair and unbiased judging process. Although the judges have already viewed recordings of these talks and submitted their scores, there's one more winner to choose. During the Q&A after all the presentations, we will open up an online poll where you can vote on the 2023 Grad Slam Showcase People's Choice Award. Stay tuned after the talks for further instructions on this. We're also grateful to our donors, whose gifts make this event possible. Making that possible also includes the prize money, which is, of course, important to students given the cost of living in Santa Barbara, not that the intellectual challenge alone would not draw students to the competition. Big thanks to Yardi, the Lopker Family Foundation, Drs. Carrie Tobes and John Lewis, Boone Graphics, Dr. William Bilo, and Dr. Sushu Ho, HRL Laboratories, the Santa Barbara Independent, and Samsara Wine Company. We also want to thank our numerous workshop facilitators and Grad Slam alumni ambassadors who ran valuable trainings for our students on public speaking and presentation skills. Their names and affiliations are listed in the program. Needless to say, our amazing graduate division staff put endless hours each year into producing Grad Slam. This year required many helping hands as we return to in-person preliminary rounds, and so many people helped that to mention them all would cut time into the program. But I must give a big shout out to John Loftus, our Assistant Dean of Development, Marge Perko, our Director of Marketing and Communication, and above all, to Sean Warner, Director of Professional Development, and her Assistant Director, Baron Haber, our Grad Slam gurus. So let's give them a round of applause as well. And now to the talks. Before each presentation, we'll see a brief video introduction that will help us to get to know a little bit more about the students. Then they will come on stage, give their 3-minute talks. So without further ado, please enjoy our amazing students and the breadth of brilliance they bring to our campus.
So this was actually an undergraduate research thesis that I did at my undergrad in UC Davis. I was not planning to turn it into a full research topic, but I was trying to write just a normal research paper, just get it out of the way senior year, whatever, for my medieval class. And then I was looking for, I thought, oh yeah, Death in Chaucer, Death in the Canterbury Tales, seems like an easy win. And then I looked, and I kept looking, and I found maybe 2 articles in the entire UC Davis library. And I talked to my professor, Dr. Claire Waters, and I asked her, I was like, do you have anything? And she's like, no, I have nothing. I talked to other medievalists, and we have nothing for you. So that means you get to do it, yay! I think finding the connections between the medieval and the contemporary has always been something I've been interested in, because people have been people for as long as we've been people, and we've always had to deal with this as an event in our lives, as a tragedy. And I think realizing that and getting to work through that has been really rewarding and also challenging, because as someone who's gone through like many, like, you know, family life deaths and such, it's kind of weird and also nice to be able to talk to other people and be like, death is actually not so scary, it's not so bad, it's just something we have to talk about. Well, I have been an avid knitter since I was 10 years old, actually. I learned as part of a club at school, and I just could not stop doing it. I can still knit, even if I'm not looking at my hands. And I only learned how to crochet about 5 years ago, because every time I tried learning, my grandmother, God bless her soul, could not keep it with me. Like, it just would not stick. Every time I would be like, how do I do this again? And she'd be like, babe, I taught you this last time. I'm like, I know, but... And then finally I learned, and I was like, oh, okay, now I get it, and everything's fun. And I really like making things for my friends and family. It's a very relaxing hobby. I'll do it after tests too, if the professor will let me. Outside of doing Grad Slam, which has actually been a wonderful thing, like truly getting to see everyone else's talks and all of that has been so rewarding. Outside of that, I think just getting to talk to my fellow grad students in the English department and working with the amazing faculty we have, and getting to hang out with the queer trans grad student unit, actually. They have been such a huge community support for me, and it's been truly just wonderful being able to find a new community down here in Santa Barbara. Everyone will die. Now, I know that's a really awkward and uncomfortable way to start a big academic presentation like Grad Slam. Not really something we start off with, but it is true. Death will affect us all in small ways and big throughout our lives. And how do we deal with that emotional impact? The existential reality that no one can live forever. I have found, as a medievalist and an literary scholar, that we deal with it through the arts. As a medievalist, I found this to be especially true of medieval art. When any illness could turn into a catastrophe, when plagues were running left and right, they devoted entire artistic genres to it, like La Danse Macabre, as you can see here, or the Dance of Death. As an English scholar, I thought to look for moments of death in one of the great works of Middle English, written by one of the founding fathers of the field. I'm speaking of Geoffrey Chaucer's Canterbury Tales, written in the late 14th century. To my great surprise, I did not find much talk of death among critics of the Canterbury Tales, which is really such a shame because the moments of death that appear in the Canterbury Tales really resonate with us today. One example of a theme of death that does show up in the tales is the moralistic dilemma of death or dishonor. Now, in this, a powerful, wealthy man propositions a woman to have sex with him and uses his great power to make it a terrible choice. She has to choose between dishonoring herself, her family, and possibly damning her soul by consenting to have sex with this man, or avoiding to have sex with this man, and in trying to do so, choosing to die, either by suicide or filicide. This has obvious resonance with us today as we grapple with issues of reproductive health, especially in places where abortion is illegal or contested. People today have to make a choice between getting an abortion and risking social judgment and criminal charges, or going through with an unwanted pregnancy and risking poverty, illness, or death. As I've thought about all of these themes of death in the Canterbury Tales, I've been struggling to find a way to encourage other people in literary studies to look at death in their works, and people across the fields to look at how death impacts their work. And I've struggled to find a concept to encourage people to do so. And then I remember a different medieval concept, that of memento mori, literally translated, remember you die. Because we all have to live life every day remembering that we all will die. So why not talk about it? Thank you so much.
Well, I've always really loved animals, and I wanted to incorporate that somehow into my engineering work, and that's what got me into bio-inspired design. And my current research project, which I'm presenting on, incorporates LAMSA, which is latch-mediated spring actuation. It's an inherently bio-inspired mechanism, and you see it in nature in click beetles, and mantis shrimp, and trapjaw ants, and I incorporate that into a lot of the projects that I'm doing now. So something about my research that I suppose enjoy, but is also a bit of a challenge, is I guess the autonomy that I'm given for this project. So I like to be able to determine the direction of my research, where it's going, but it's also a bit of a challenge trying to manage my time along with the other projects that I'm working on. But it's always nice to see it come together at the end, especially if you get to publish it or present it at a conference. I like to draw comics, and I like to make 2D animations by hand. And I'm also starting to dabble a bit in 3D animation, which you see a little bit in my presentation, which I did a 3D render, and then I drew on top the sketches. I think my favorite experience, again, is that conference I went to in Japan. We went to Kyoto for about a week, and the entire lab went with me. So one, it was nice going to a conference and meet other people who are also interested in this work, which is great, but it's also nice just to explore the city with the rest of my lab mates outside of the lab. We got to go to some of the tourist destinations together, or eat the food together at different restaurants. So that was very enjoyable. Jumping on air. Now this sounds like something out of fiction, or maybe a game where you could double jump. But today I'll show you how we can make drones jump on air to increase maneuverability. Now, in the world of drones, there are 2 main categories. The first being rotary drones, like quadcopters. And these are capable of dynamic mid-air maneuvers, but they're inefficient. Their flight time is highly limited, and they're dependent on their rotors. On the other end of the spectrum, we have fixed-wing drones. Now, due to their wings, they can generate lift. They're suitable for longer surveillance missions, but they have lower maneuverability. For example, if you want to make a turn, you have to do so in larger sweeping motions. The vision, then, is to create a fixed-wing drone that is also capable of dynamic mid-air maneuvers. And by being both efficient and maneuverable, you're combining the strengths of both categories. Now, such a drone could be useful, say, in package delivery or even disaster mitigation. If you're navigating a collapsed building or a cluttered environment, it's important to do sharp, sudden turns. But current fixed-wing drones have too wide of a turning radius, and rotary drones too short of a battery life. We can think of another application, say a crowded urban environment, where the drone must perform an instantaneous vertical jump to avoid collision with oncoming traffic. But this begs a question. How? How do we create a drone that exhibits these properties? In our proof of concept prototype, we had 3 main components. First, our drone is comprised, or our glider is comprised of 2 bodies, where the wing is pulled apart by a latch, and they're pulled together by a spring. Second, you need to introduce asymmetry to your system. If you had 2 equal masses colliding, as shown to the left, you have no momentum, no jump. But if you add a high drag wing to the top mass, after collision, you now have a net upwards momentum, giving you our jump. And lastly, we need to introduce even more asymmetry by adding wing flaps. So if the drone is going downwards, the flaps close, high drag. And when you're jumping upwards, the flaps open, low drag. And putting all these three together, we can demonstrate a working proof of concept prototype of midair jumping. And just as a quick recap, you begin in a gliding phase. A latch is released. The bodies collide and jump upwards. And then you continue gliding, but at a higher elevation. And we show here one more example of obstacle avoidance. And even though here it's just jumping over a cardboard tube in an empty room, in the future, giving drones this jumping capability will allow them to navigate cluttered environments while also maintaining long flight times. Thank you.
So I'm a graduate student who's undocumented and was born into poverty. And naturally, when you come from such impoverished conditions, that can definitely impact the ways in which you communicate and maintain relationships during stress-evoking situations. And in my research, that is exactly what I want to do, is learn more about why I had certain experiences during childhood, but more importantly, allow that learning and understanding to inform other people's lives and help them more effectively and constructively communicate, especially during difficult times. One of the most rewarding aspects about my research is simply producing knowledge about relationships and how they affect people during difficult times. Now, through the support, guidance, and training that I received from my wonderful co-advisors, Dr. Tammy Afifi and Andy Marola, I have learned how to carefully and meticulously design studies that can tap into this idea of relationships affecting how you get through difficult times. And my research is simply to help others understand more effective ways of communicating, especially during conflict or tension or disagreements, so that they can have more meaningful relationships. Something that people are quite frequently surprised to know about me is that I am an undocumented, first-generation, and previously homeless undergraduate student and graduate student, and people often tell me that they cannot fathom how I continue to have this motivation and determination to pursue my goals despite having such dire circumstances and extreme disadvantages in life. And I think that a lot of people pursue goals or set goals simply for attainment purposes, like being able to get success so they can attain wealth or have a big house or money or a thriving business. For me, however, I set goals to prevent certain things from happening. So, for example, I work really hard at whatever I do so that I can prevent my future generations from experiencing some of the disadvantages and circumstances that I grew up in. So my goals are more strictly related to prevention rather than attainment. I believe I speak for all graduate students when I say our favorite experiences in grad school are the breaks that we get in between quarters. But a close second would be simply forming deep connections with some of my graduate peers. I am not someone who rolls deep with a squad. I am very selective with who I allow to enter and remain in my life. So being able to meet some of these amazing, intelligent, but also humble, compassionate, and entertaining graduate students has been wonderful, and it's made my journey at UCSB memorable and amazing. During the pandemic, married individuals got a taste of what life might be like to spend every second of every day with their partners. And judging by the look on many of your faces right now, That taste may have been, well, distasteful. But why did some marital relationships flourish while others struggled? Hey everyone, I'm Abdullah, and today I'll share my research on marital resilience during quarantine. To begin, the theory of resilience and relational load explains how married individuals respond to stressful situations using two concepts. First, communal orientation, or CO, is defined by perceptions of marital unity between partners and is developed by relationship investments, such as saying, "I love you," or taking your partner out on a romantic date. CO builds resilience, buffers against stress, and provides relational stability during adversity. Second, relational load, or RL, refers to relationship burnout caused by recurrent patterns of conflict and has the direct opposite effect of CO. Now, a lot is known about marital resilience and unity as outcome variables, but research on resilience as a predictor is still developmental, leading us to our prediction. We predicted that married individuals who entered the pandemic with more resilience and marital unity would have relationship stability, namely less stress and conflict, but better mental health and flourishing at baseline, which would remain stable across time. Moving on to our methods. 3,601 married individuals responded to surveys concerning all variables across 4 time points, from April to June of 2020. And after data were analyzed, the results revealed married individuals who entered the pandemic with higher levels of marital unity and resilience had less stress and conflict, but enhanced mental health and flourishing at time point 1, which then remained stable throughout quarantine, supporting our prediction. Well, what did we learn? First, the study highlights how marital unity and resilience may provide relational stability in the face of a stressor that could destroy a marriage. Second, the study captures the importance of investing in your relationships before stressors occur. When you invest, don't give the same compliment every time. If your partner has beautiful colored eyes, for example, look deeply into them and say, "Babe, you have beautiful eyelashes." Lashes. Mix it up and keep it interesting. Lastly, the study highlights the need for future research on resilience as a predictor, not just an outcome variable. So, the next time you enter a stressful situation, what relational qualities are you bringing to the table, and ask yourselves, are you leaving this table with a good or bad taste in your mouth? Thank you.
So I work in theoretical computer science. So I essentially design algorithms for various problems. One aspect of my research that I like is that I can design algorithms for problems from various domains or like various disciplines, as long as they can be expressed mathematically. And that is in fact how I got involved with the kidney exchange problem that I'm talking about in Grad Lab. So here I feel like, especially if I have to talk about the kidney problem, right? So people can relate to it. So when I talk to friends or family members, they understand what I'm doing, and it's also really relevant. So it motivates me further, knowing that it helps people out there, and the thing that even though it's not like implemented directly as of now, the hope that it will be at some point motivates me to pursue more research. I'm a person who keeps humming the whole day. Like there's some song running around, like I always sing. But the thing is, I always mess up the lyrics. I introduce my own lyrics to songs, right? And then when I have people who understand it, they're like, oh no, you're like messing up the song. But fortunately, I like sing mostly in my mother tongue and people around me don't get it. They're like, okay, it's a good song. I'm like, yeah, you don't understand the lyrics. Oh, Santa Barbara, it's definitely the beaches. I work from Harold Frank Hall, which sits right next to the beach, right? I have a beach view. And also, if I want like a mid-work day stroll along the beach, this is like 2 minutes away. I can go to the beach and relax and come back. Thank you. The global kidney dialysis market is worth $90 billion. As of today, in the US alone, there are more than 1 million patients waiting to receive a kidney transplant. The wait list only keeps growing longer and longer each year. In fact, patients having certain forms of cancer, such as breast cancer and skin cancer, have a much higher rate of survival than patients undergoing kidney dialysis. All this has seen the issue of matching kidney patients with donors receive a lot of attention in the recent past. Kidneys are special organs. We can continue to live a normal life even after donating one of our kidneys. So, in many cases, a patient's friend or family member comes forward to donate one of their kidneys. But their kidney might not be compatible with the patient. In this case, what do we do? So, the kidney pair donation program has been introduced in many countries to help such patients. In this program, a patient enrolls as a pair along with their own incompatible donor, and the goal of the program is to help such patients by using cyclic exchanges such as the one shown here. Here, every patient on the cycle receives a kidney from the donor before them in the cycle. So for example, patient C receives a kidney from donor B, while patient B receives a kidney from donor A. All right, but how do we conceptualize this? Let's take a simple example of 8 patient-donor pairs. Here, the arcs represent compatibility. We can find a cycle helping 3 patients, but we can also find a set of cycles helping 7 patients. We obviously prefer this one because it's helping more number of patients. Thus, our goal is to find a set of cycles that help as many patients as possible to receive kidneys. But when the number of patient-donor pairs increases, this problem becomes really hard really fast. In reality, there are tens of thousands of patients. This is where I come in as a computer scientist. Such problems in computer science usually turn out to be very hard to solve. But fortunately, experiments have shown that there are only a few types of patients based on certain factors, such as age, blood group, and other biological markers. So I use this in my research to design algorithms to find cycles. And these cycles help as many patients as possible to find kidneys. Ultimately, my research acts as Cupid for patients, helping save thousands of lives. Thank you.
I feel like a lot of molecular biology projects tend to be kind of like Frankensteining things together, or at least that's how people think of them. And I liked this project because rather than kind of creating something new, I was going to look at what already is And the world has already Frankenstein so much cool stuff on its own. It was cool to be able to like uncover a secret of sorts is kind of how it felt. So I really liked that about the project, that I was gonna go out and observe what already was. I think challenging, I have the same answer that probably most all researchers have, which is dealing with the uncertainty. I didn't know, first of all, if this was going to work, and then even if it worked, I didn't know what I was going to find because no one had looked at these worms before. So that was really scary. But then on the flip side, it was rewarding because I did find something, and it kind of re-inspired me that like if you just look around, there's a high probability you're going to find something cool. So it was rewarding to go through that whole process. One fun fact is I'm trilingual. I speak Spanish because my family's Dominican, and then I also speak French because I spent some time in Switzerland. I've met a lot of really, really cool people. Like I've never been in a space where there's so many people that also like to like obsessively dive into one thing, and they have a lot of really cool interests, and I've just learned a lot from the people I've met here, both like in work, outside of work. Made a lot of new friends. Santa Barbara is a really friendly place. On the rare occasion that I decide to partake in the activity of watching sports, I often find myself marveling at how these athletes never seem to run out of energy. Aside from the protein powder and the endurance training, I think they probably have some pretty good mitochondria. Very well known to many of you as the powerhouse of the cell, it's responsible for all of our cellular energy and therefore essential to human function. Now, typically, when we think about human function, we look to our DNA that's kept in the nucleus. But what you may not know is that we also have DNA kept separately in our mitochondria. In addition, we have tens of thousands of mitochondria per cell, each with their own DNA encoding proteins that make energy. Unfortunately for us, this DNA is super susceptible to damage, and that damage can spread. And what will result is a cell with both good mitochondria and defective mitochondria containing bad DNA. And we see that it's actually the levels of good to bad mitochondria in our cells that will determine how badly a disease might present. Because of this, there is a wide range of mitochondrial disorders, ranging from debilitating to lethal, and this even includes diseases like Parkinson's and common cancers. This leads me to my research question. Can we lower the level of bad mitochondria in our cells? Or even better, can we clear them out completely? Now, we haven't yet found a way to do this, but I might have just met some little friends among us who can. Meet the C. elegans nematode. These guys are used widely in genetic studies because, crazily enough, they have a lot of really similar genes to us. And despite there being many different wild populations that span the globe, researchers have really just focused on one, isolated in Bristol, England. Now, this worm, he's pampered, right? Everyone uses him, so they're always in a very comfortable, lab-controlled environment. So I thought maybe some of these other somewhat neglected worms find need to use a little bit more energy. And so began my search. I put the same bad mitochondria in various worms from around the world to see if any of them might be better at naturally clearing it out. Now, the type of bad mitochondria that I study, we've only ever seen take up 70% of the cell. This number never budges. So I was surprised when I found that worms from Seattle brought this down to 67. Then worms from Hawaii and Taiwan got close to levels of 50. And worms from Portugal even brought it down to 25. Yes. But shockingly, these were not the champions of my search. Turns out the best mitochondria actually came from right here in our own backyard. Worms from Los Angeles, California, were able to bring the level of bad mitochondria down to 0%. resulting in complete clearance. Going forward, I have one main question. What do all the top contenders of my mitochondrial search have in common? This way, I can zero in on a mechanism responsible and hopefully one day use it to beat mitochondrial disease. Thank you.
Well, what I study is a very beautiful problem and has so many connections through all mathematics from different fields. In particular, I study geometry, but I love my problem because I can apply it, I can talk with other grad students, other professors from all different fields, and still find a connection to discuss, to talk about it. We can apply it in physics, we can apply for us, I study geometry, so other people that study analysis of topology, they're very, very different from us, but somehow my problem is also related to their problems in some sense, because it's a very, very kind of a fundamental question we try to ask in mathematics. And so it's a beautiful connection towards physics, math, and everywhere else. So it's very beautiful. The way we do research, the way I explain it, I think about we have a dark castle, a big castle with a lot of rooms, hundreds of rooms. But the castle is dark, so there's no lights. So what you do, you go into the castle in the first room and turn on the light and look around and see for what is the next room is. Then you go to the second room and turn on the light again, and very slowly you keep through the castle. But when you arrive at the end, or close to the end, you forgot what was in the first room. So one of the most challenging part about research in math is to keep track of all this flow of what's happening, because we try to abstract problems so hard that sometimes we really forget what we're talking about. I make pizza from scratch. So during the pandemic, everybody started baking bread. And for me, as Italian, bread is kind of like putting on the side in a dinner. And I like pizza much more, so why don't we start baking pizza? And I've been studying through the whole pandemic, and some people may say that now I'm a little obsessed with it. So I make it from scratch. I have 2 pizza ovens at home, and my pizza oven rotates. It's a whole story. If you want to know about it, please send me an email. Share my pizza journey with you. It's hard to choose one because I had such a great time here. I love being here. I feel very privileged to be here. As an immigrant from Italy, I couldn't really continue my studies back in Italy. I had to move, and so I feel really amazing to move here. And I got stuck here during the pandemic, which is a beautiful place to get stuck. And I have amazing friends here in grad school, so I cannot really pick a specific activity, but I really love just hanging out and working here. It's such a great place to be and to live. So I'm very lucky. Too many of you may think that math is boring and completely pointless. And too often, this is true. But not today. Today we use math to learn about pizzas. Today we answer the question, why are pizzas usually round? In applied sciences, when they have a research problem, they attempt to solve it or show it cannot be solved. Eventually, one day, they will run out of good problems. In mathematics, it's very different. When we have a problem to solve, we generalize it and create a bigger, scarier problem that solves the smaller problem, and then leave the bigger problem for someone else to solve. This idea of recycling problems makes our research method very sustainable, very eco-friendly. The problem I'm going to discuss today is the Monge problem. And this is how it works. We are given a pile of dirt, and we want to use it to build a castle. But moving the dirt in the most efficient way possible. I study the beautiful and elegant connection between optimal transport and geometry. The connection is found in what we call the isoperimetric problem. Iso means the same, perimetric, it's perimeter or boundary, so we study shape with the same perimeter. The problem is an equivalence of definition. Let me show you with a simple shape. The sphere is the set of points at a given fixed distance to a center, as you can see on the orange shape on the right, as opposed to the green square. This is also equivalent to say that the sphere is also the shape that, given the perimeter, maximizes the volume inside. Through the whole animation here, the perimeter stays the same, while the volume gets bigger and bigger. What is truly amazing, that both of these definitions of the sphere are equivalent to say that it's satisfying equality in the isoperimetric inequality. And before you panic, this is the only formula I'm going to show you today. All the other shapes do not satisfy the equality sign here. They're just strictly bigger. In my research, I studied this inequality using tools from optimal transport. This blob is like a pile of dirt we turn into a castle in the Munch problem. But this time, instead, we want to find the most efficient way of turning the blob into a sphere while still preserving the perimeter. In some sense, we are filling up the shape in the most efficient way possible. This formula is big and scary, and for someone else to generalize. Instead, I want to answer the related small, yet crucially important question: why are pizzas usually round? Because given the amount of dough, you want to maximize the topping content. And the circle does just that. I hope you at least gotten a glimpse of why math can be as beautiful as my pizzas.
Well, I think my interest started from my personal experiences as a bisexual person. Growing up in rural China, it was really difficult for me to find any communities. I started organizing events for the queer community in China, and still there were not many research findings for me to educate myself and my community. And I've been studying psychology all my life since undergrad. I thought I can put my research skills into use to benefit my community. Yeah. Yeah, there are so many rewarding aspects of my research. While doing this research that I just shared, I connected bisexual communities in mainland China, Hong Kong, and Taiwan. I was able to hear about LGBTQ movement in Taiwan, and I organized a webinar inviting bisexual experts to share their expertise in helping other people combat the stigma and prejudice bisexual people face in their daily lives. So I find it super rewarding that I'm able to use my skills and experiences to help others and help my communities. So yeah, I worked before my graduate schools. I was sponsored by the Chinese government to work at UNESCO headquarters in Paris, and then Asian Pacific Regional Office in Bangkok, where I promoted gender equality and LGBTQ inclusion in the educational sector, like through international programs and policy advocacy meetings. And then I love traveling. I've traveled to many different countries, probably maybe around 25 different countries. So yeah, first I didn't really like Santa Barbara because it's small, it was isolating, and then the pandemic started. And then now one of my favorite things is to surf in Santa Barbara. I learned how to surf and enjoy surfing. I enjoy watching sunsets while waiting for waves to come. I'm just a beginner, but I just enjoy being in the nature in Santa Barbara. About 4 years ago, I took a 14-hour long flight. I left my family to come to UCSB. with a scholarship focusing on the mental health of LGBTQ populations. I was so excited because I couldn't find such a program in China where I can specialize in LGBT psychology. As a bisexual scholar, I wanted to better understand the experiences of my communities and share their voices. However, when I started looking into literature, almost all the studies I found about bisexual mental health were conducted in the US or other Western countries. Weird, right? Well, psychology actually has a long history of publishing broad claims about human behaviors based on samples drawn almost entirely from Western, educated, industrialized, rich, and democratic societies, which house only 15% of the population. Weird. To discontinue weird conclusions, my research has been focusing on experiences from Eastern countries, such as China, which has the largest population in the world. And bisexual people form the largest group within the LGBTQ community, more than lesbians and gay men combined. There are actually about 40 million Chinese bisexual people, underserved and understudied, and their voices deserve to be heard. So I reached out to my communities and interviewed 12 bisexual leaders and laypersons. I surveyed over 700 bisexual people based in mainland China, Hong Kong, and Taiwan. I laughed, I cried, and I mourned with them as they share their unique challenges with me in Chinese cultures that center on family values and respect for parents. One participant, a bisexual man with the same gender partner, who has been out to his family for more than 5 years, but his parents are still asking him to marry a straight woman and have children. His straight friends think he is just gay and afraid to admit it, and his gay friends are worried that he might eventually have to marry a woman and betray the LGBT community. So that's very hard. However, I've also discovered so much strength and resilience from my participants. One participant, a bisexual transgender woman, is married to her partner in Taiwan, and she organizes incredible pride events for bisexual communities. Together with a group of amazing bisexual activists, I co-authored one of the first menus about bisexuality in Chinese that is helping so many young people accept and affirm their sexuality. Finally, I want to say, by listening to the stories that are unheard, as I did, psychologists and social scientists can stop being weird. Thank you so much.
So my undergraduate is in geology, which was inspired by my interest in environmentalism. But now I study hydrology, and that's an easy slide from geology to hydrology. And the reason I'm interested in water is because it's very easy to care about. Every living thing depends on water, and water is not just an environmental issue, it's also a social justice issue. So I would say the most rewarding and challenging aspects of my research is when I do field hydrology. So you might know that saying that man makes plans and God laughs. So it's more like I make plans and nature laughs at me. And nature has definitely been laughing a lot, especially with all the storms in California the past few months. So a lot of my equipment has actually washed away. Which is challenging, but for the stuff that has stuck around that I'm able to find, it's really rewarding when I get it. So I think being a scientist, some people might be surprised to know that I have a long history in musical theater, and acting is something that I really enjoy. So that's a hobby that I'd like to get back to after graduate school. It's kind of hard for me to pick just like one example or thing, but I think if I were to say like my favorite experience of graduate school is the people that I've been able to work with. I have an amazing advisor, and everyone in my lab group and like the peers of PhDs in my department, as well as the undergraduates I've been able to mentor. The community is definitely my favorite part of grad school. Did you drink water today? If the answer is yes, and you drank that water from anywhere in the United States, there's a 50% chance that water came from underground. Although it may seem invisible, groundwater is everywhere. We rely on groundwater for the water that we drink, water to grow our food, and to maintain the ecological habitats that we enjoy. Unfortunately, groundwater is in trouble. Humans use a lot of groundwater, and groundwater loss is connected to all kinds of problems, including drinking water contamination and even the sinking of the ground itself. Groundwater management is such an important topic, it's landed in the Supreme Court. So how can we sustainably manage this resource? Well, in environmental science, we try to look to the past in order to better predict the future. But in the case of groundwater, this has been a real challenge. Most records we have of groundwater in the United States only go back to the 1940s. But by then, we had already been using groundwater for at least 70 years. So how can we expect to manage groundwater if we don't even know what it was like when we first started to use it? This is the problem I try to address in my research by reconstructing groundwater measurements from the late 1800s and the early 1900s. So, it turns out these measurements actually exist. They've just been forgotten in some very old US Geological Survey reports. I led a team of 5 students over the course of 6 months to help me hand transcribe and digitize over 10,000 early groundwater measurements. Here's what I found out. It turns out groundwater was a lot different in the late 1800s than it is today. There was a time when groundwater used to gush out of wells onto the land surface, like a fountain. In the same areas where groundwater was so abundant that it would shoot out of the ground, today, wells are going dry. Out of all the wells that we looked at prior to 1910, 61% of them were flowing wells. But post-2010, only 5% were flowing. Not only does this historical information give us an idea of the amount of groundwater there could have been in the past, but it also tells us something about the way groundwater was flowing underground, which is connected to the problems we face today, like contamination and the sinking of the ground surface. Using these historical measurements, we can make better decisions about how to manage groundwater for the future, so we can protect the water that comes out when you turn on the tap. Thank you.
I was always fascinated how materials with specialized properties are being produced. However, with the growing environmental pollution, it became essential not only create useful materials, but sustainable ones. Today, I am excited to present my research on plastic recycling. The most rewarding and at the same time challenging part of my research is creating new materials. As a synthetic chemist, I have to set up reactions every day and hope that they will work. As you can guess, most of the experiments usually fails, and I have to be very patient and consistent to succeed. However, this helps me to grow as a person. One thing people would be surprised to know about me is that I have recently sent my molecules to the International Space Station to investigate how light interacts with fluids without gravity. We call them space bubbles. We found out the fundamental physics of how light works with bubbles and how the surface tension changes by shining light. My favorite experience in grad school is meeting and working with new people. I'm grateful to be at UCSB, which has one of the most collaborative environments. I enjoy conducting my research and exchange knowledge and expertise with graduate students from various departments such as physics, chemistry, materials, and engineering. Have you ever been standing next to the recycling bin and thinking, can I put this bottle in it? Will it even be recycled? And if yes, how? If you look into a trash can, you will find various types of plastics, and they all have numbers corresponding to the polymers they are made from. Polymers are essentially long chain molecules formed from other small molecules or monomers linked together. Because we want unique properties of our materials, the chemistry of polymers is very dissimilar. And that's the main challenge. If you would even take plastics made from the same atoms, carbon and hydrogen, but with different arrangements, like in polyethylene and polypropylene, and melt them down together, you would get a material with terrible mechanical and optical properties due to poor mixing. These two polymers dislike each other so much that they macrophase separate, like when water and oil are mixed. That's why the industry has to sort each type of plastic separately, even your water bottle and its cap, which takes time, money, and energy. And even after doing that, they still can recycle only limited kinds of plastics. To improve this process, we're introducing ions. Ions are charged species, in our case, molecules. They can be positive or negative. They attract and form strong interactions, which are difficult to break in the solid state. By applying chemistry, we put on one polymer positively charged groups, and on the other one, negative charges. We have already demonstrated that by introducing just one pair of oppositely charged ions on the chain ends of unlike polymers, we can significantly improve the compatibility of the system, and as a result, physical properties. You can simply monitor that by the change in optical clarity of our materials. As our model system worked, we're now applying this strategy to the real industry by processing post-consumer plastics, on which we introduce just a little bit of ions, mixing them together in a special machine under high temperature, and producing recycled materials with high performance. By doing this, you won't have to worry about your water bottle anymore. Thank you.
Wow, aren't they fabulous? Let's give them a big round of applause. What an amazing range of topics. I'm now prepared to have something to say about death, drones, marriage, kidneys, worms, pizzas, bisexuality, groundwater, and ions. So if any of those topics come up at the next cocktail party I go to, I will be all set. So we're now ready to move on to the Q&A and people's choice voting process as we get the stage set up. After this is all in order, we'll have all the presenters come back up on stage. In the meantime, we're officially opening our People's Choice voting form. You have 10 minutes to cast your ballot, so don't dawdle. You can scan the QR code or enter the URL into your device. You'll have to be signed into your Google account to vote. I know this is a really hard choice. They were all so fabulous. Okay, there's the code. Our 7 judges for the final round provided individual questions for the presenters as they viewed the videos and submitted their scores. I may have a few myself, but we've worked the students pretty hard already this afternoon. So we're all now also in a state of anxiety before we find out who the winners are. So I'll invite everybody to come back up. Okay, so I'm just going to start with a really easy one. What's your favorite place on campus?
My favorite place on campus is eating lunch behind UCSB and facing the lagoon.
I would have to say that my favorite spot is the ocean-facing staircase in my academic building, Bren Hall, because it's a great view of the ocean, and whenever you're going out to a meeting or switching floors, it's nice to take a break and look out.
So we're getting a theme here and some jealousy from the other side of campus.
As someone from the other side of campus, there is a little jealousy. But I do really love the community research commons that the English department provides in South Hall. It's so nice to be able to meet other students as we're just trying to get papers done.
My favorite spot is like the walk from Harold Frank Hall to Campus Point. Harold Frank Hall is my office building. Yeah, the walk is really pretty. Like you can see the ocean all around. Yeah.
I've said this a lot, but Courtyard Cafe has really good tacos. And that is one of my happy places on campus.
My favorite place is the Ocean View by Ealing's Hall. It also has a lot of beautiful flowers to enjoy.
My favorite spot is the 4th floor of the SSMS building. It has a gorgeous view, and also my office where all the homies kind of have fun with our conversation, so.
I would also say my office. I have a beautiful ocean view, so.
In my case, I really like the lagoon and just walking around it and looking at the different birds that are there at the morning.
Great. Okay, so on to some of the questions that were submitted by the judges. So Changjian, I'm going to start with you. Can you tell us more about the challenges faced by bisexual people that are unique to Chinese culture?
Yes, of course. Yeah, thank you for this question. So in the Chinese culture, there's a lot of pressure coming from the family for you to establish a marriage, and usually a heterosexual one with offsprings, because it's considered a shame for you to not be able to continue the family line. So actually, in mainland China, there are many lesbian women and gay men. They would have a contract marriage, a fake marriage, basically, to maintain the face of the family. So for bisexual people, even if they choose to be in a mixed gender relationship, they might be stigmatized as having a choice, right, to be able to choose the gender. Yeah, so that's just one example I want to give. Yeah.
Thank you. So for Annette, is California still in a drought?
Okay, so that's a good question. I know a lot of people are thinking about that right now with all of the atmospheric rivers and the massive amount of rain that we got this winter. While drought is not my area of expertise, from what I understand, about 90% of California that was formerly in extreme drought is no longer in that like extreme version of the drought. There's still a lot of areas that are dry, but it's definitely been a good season for drought in California. But I do want to say that, unfortunately, that doesn't really make too much of an impact on groundwater depletion. That's been going on for a lot longer. Thank you for that question.
This is one of my own, but I just have to ask quickly, if you can, like, how does the water get into the groundwater?
So that's like...
I know it's not a simple question.
That takes like a long time, but...
I figured.
One thing I would say is that a lot of water that ends up getting into groundwater does come from snowpack. So snowpack is very important. But yeah, groundwater recharges, it really depends, but some groundwater recharges on scales of hundreds to thousands of years. So it takes a really long time for water to get in there.
Longer than we use it up faster than it takes to do it, I know that. Anna. Yeah, great. Can you explain more about the potential applications of a drone with these capabilities in disaster mitigation and package delivery?
Right. So in my presentation, I talked about the two types of drones. For a fixed-wing drone, those are superior in general for longer flight times, longer distances, even for sound pollution. But the main disadvantage of the current ones is that they can't really navigate tight spaces. So by incorporating the jumping mechanism that I have, you'd be able to allow them to do that sudden obstacle avoidance. So essentially, this jumping fixed-wing drone that I was presenting on, you can use it basically for any application current fixed-wing drones do, smaller ones, but also with the added benefit of obstacle avoidance.
Great, thank you. Next for Ksenia. How do you envision this technology impacting the plastic industry and the environment in the long run?
Thank you for this question. It's really difficult to answer it shortly. But as you know, most of the plastics are not compatible with one another. They simply just repel. And I believe that industry has an opportunity to introduce just small amount of ions, like close to 1%. And when we will have on one type of polymers positively charged groups and on the other one negatives, then after the plastic utilized, we can just collect it together, remelt and produce a new material. And even more, after this material being thrown away, we can take it again and break into the other parts. So we will be able to recycle one material or two materials many, many times, and then we won't have to produce so many new materials. And this way, we will be able to reduce waste accumulation.
Vaishali, are there any ethical concerns or challenges associated with kidney exchanges, and how are they addressed?
Yes, there are, because it's medical data, right? So it's always hard to get medical data because of all the, like it being personal and people not willing to share it. So that is one concern. But apart from that, one thing super relevant to what I was talking about is, when I talked about cycles, like, patient-donor pairs and cyclic exchanges. So in this, what happens is if you allow longer cycles, like say 10 or 15 people, right? Donors are not willing to donate their kidneys before their corresponding patient receives the kidney, right? And sometimes what happens is when patients receive the kidney, the donors go away. They're like, oh, my patient has received the kidney, so now I don't have to, donate my kidney because my friend's already been helped, right? So at least like in real life, we tend to keep it small, cycles of like 3 or 5. I think there's been a 6-way operation too. So these are some ethical concerns in that space. Yeah.
Thank you. Gail, how do you think studying the arts and literature related to death can help individuals cope with the emotional impact of death?
I think that there's a concept in literary studies of catharsis, and most people are aware of it. It's when you watch something that's really hard, that's like touches on grief or trauma, and you're able to express the emotion and access those feelings without having the individual trauma of a sudden death coming for you. And so there's a way that dealing with those emotions ahead of time can help mitigate the future trauma of a sudden death, and you're actually able to healthfully grieve and go through that loss without necessarily getting the traumatic stress that we are all so concerned about and happens frequently in sudden death.
Okay, thank you. Abdullah, can you share more about the specific survey questions used to measure communal orientation and relational load in your research?
Yeah, thank you for that question. So to capture communal orientation, which is this idea of marital unity, we use specific questions or items that were framed as, my partner and I approach stressors as a team. When stressors occur, my partner and I work together to manage the stress associated with the stressor. In terms of relational load, we captured that with items that represented language such as, I feel personally burnt out in my relationship, or I have grown to become more insensitive or uncaring toward my partner, which would capture this idea of burnout. And those were some of the items that we used to measure the two constructs.
Thank you. I have to ask you this one as well.
Yeah.
In addition to complimenting each other's eyelashes, how else can couples increase their CO? I couldn't resist, sorry.
Yeah, so in the paper, we cited an author, Joe 2020, who recommended a relational intervention grounded in respect, recognition, and rewards. So in order to make sure that you build marital unity and resilience, it's important to recognize your partners, not just for grand events like anniversaries or Valentine's Day, but for the mundane day-to-day things that they do for you to take care of you. And that's one way to enhance that resilience and unity between partners.
Okay, thank you. Samantha. I couldn't resist this one either. Why do worms from Los Angeles have the best mitochondria? Is it, and this is the part that's so great, is it because the weather is warm?
This is my favorite. That's so good. The answer to that is I don't know yet. We're still trying to find, the exciting part is that the worms come from all over the world, but really it's that they're genetically divergent. So it's something in their nuclear DNA and how that's talking to the mitochondrial DNA that affects how the bad mitochondria is handled. But maybe, we'll see. Maybe they're just happy, warm, comfortable.
Laid back.
They're like, I don't need the bad stuff. Yeah.
Okay, thank you. And last, but definitely not least, Fabio. What advice would you give to someone who is struggling to understand math concepts?
That's a great question. I don't know a good answer, but I would just keep trying. It's always a good idea. But remember that math, as you can see here, math is very useless. So when you keep trying, it doesn't look like you're doing something useful, which is correct. But my advice is just not to give up anytime.
Fabio already said you don't ask anything about practical implications. But I do have to ask you this one as well about the which topping. Oh, now that we know circles maximize the space for toppings on pizzas, which topping maximizes its taste?
Well,
not a math question. Obviously.
Yeah, that's okay.
Your chef question.
Definitely not pineapple. I believe. Yeah, I believe pineapple on pizza is completely illegal. But you can. There are a lot of toppings that allow. And my favorite like squash blossom, which is like the zucchini flowers on top of the zucchini, and it's beautiful just with cheese. Or like even a margarita, classical, simple flavor, well done. Literally anything by pineapple, I would say.
Thank you all. So that concludes our Q&A. People's choice voting is now closed. So I'm going to ask everybody to go back to their seats so we can have a dramatic moment up here. So now I'm going to invite Jeff Meyerhoff, last year's Grad Slam winner, to join me on stage to present the prizes. And I have to say, some of our staff know who won already. I chose not to know the results in advance, so I'm as excited as everyone else. Now we're at the moment you've all been waiting for, and here is the envelope. Jeff, you're ready. And starting with the People's Choice Fabio Ricci. And our runners-up, as I told you, are unranked, so we have two. The first I'll announce is Abdullah Salahuddin. And our second runner-up is Samantha Fieo. And the grand prize goes to Annette Hilton. Wow, what an exciting event. I want to thank again our judges and sponsors, thanks to our grad division staff who made this all possible, and also to the always on top of things Campbell Hall staff, Eric and Avery. And thanks to all of you, our enthusiastic audience, in-house and virtual, for being here this afternoon. But most of all, thanks to our fabulous finalists. Let's give them one more round of applause. Don't forget to tune in to the UC-wide competition on May 5th, where you can cheer on Annette and vote in the People's Choice Award in that competition. I hope you all have a wonderful evening thinking about how much you've learned about so many things in 9 3-minute segments. I hope you feel as cheered as I do by the brilliance and passion of our graduate students. Thank you so much for coming.